All right, so the first part of a triangle that we are going to review is something called an altitude. Altitude. Y'all should have heard that term somewhere along the line in your study of geometry, but let's just review it just in case. An altitude connects a vertex to the opposite side, forming a what kind of angle? What kind of angles do I have there in the picture? Right angle, right? So there are 3 altitudes to every triangle. You can connect each vertex to the opposite side with a right angle. So that is what I'm showing there in those. That's the same triangle. I'm just showing the 3 different altitudes there. Now, if I put them all on one picture, the 3 altitudes meet at a point. So notice they all 3 intersect in this triangle. It's very close to the peak there. We call that the center called the orthocenter. They have kind of weird names, so we've got some new vocabulary to learn here today. But that is called the orthocenter, that point where the 3 altitudes meet. Now, there's a sentence, because there are 4 of these centers that we're going to learn about. There's more than 4, but there's only 4 of them that we're going to learn about. There's a little sentence that will help you remember what part of the triangle forms which center of the triangle. So the first 2 words of the sentence is all of. A stands for altitude. O stands for the orthocenter. So the first letter stands for what part of the triangle forms it. The second letter stands for which center of the triangle are we talking about. Now, I just have one picture of one triangle on here. Let me show you how the orthocenter can be located in different places if our triangle looks a little bit different. So here is another triangle with the 3 altitudes drawn. So from vertex A to the opposite side, vertex B to the opposite side, vertex C to the opposite side. So you'll notice this orthocenter is not as close to the vertex or one of the vertices as ours was. If I move A over here, notice how that orthocenter is moving. What if I move C over here? All of a sudden that orthocenter isn't even inside of the triangle. So here's the altitude from A. We have to extend it backwards out of the triangle to form it. But it doesn't matter. This is what we're looking at. The orthocenter can be outside of the triangle. It can be inside the triangle. It can be on the triangle. If we have a right triangle, that orthocenter is on the vertex that has the right angle. But I can move it around, and it can be in different places in relation to the triangle there. Okay, so orthocenter, there it is. All right, let's look at another one. Let's talk about the median. The median. A median connects a vertex to the blank of the opposite side. Now, just looking at those pictures, does anybody have a guess as to what that word would be there? Okay, think about a median in a road. Where's the median in the road? It's in the middle of the road, right? So if we're talking about the middle and we're talking about geometry, how about the midpoint? Okay, it connects a vertex to the midpoint of the opposite side. So let's label some things here on these pictures. So that is the midpoint. So that means that this segment and this segment have the same length. Okay, just remember when you have those little tick marks, it means that they are the same length. Let's actually put a length to it. Let's say that we've got 5. So if that part's 5, then this part has to be 5 because it is separated, or it is created by the midpoint there. If we connect the other vertex or one of the other vertices, okay, those segments have the same length. Those look a little bit shorter. Let's say that they're 3. They're 3 apiece. Okay, I know it doesn't look like it, but these are all three the same triangle. They look a little weird when you put those medians in there. Okay, but then this third one, those two segments are the same. Let's say that they are 4 units each. 4 units each. Okay, so if we put all the medians on one triangle, that's what I have in that illustration below. They intersect at a point, and that is called the centroid. Okay, that is called the centroid of the triangle. All right, so here's something special about the centroid. It splits these medians into proportional pieces. So the distance from a vertex to the centroid is twice the distance from the centroid to the side of the triangle. So that's really wordy. Let's break it down. The distance from a vertex to the centroid. So from a vertex to the centroid, this piece is twice from the centroid to the side of the triangle. You can kind of see that in the picture. It should look like it's twice as long. So let's say if this part of our median is 1, then this piece of our median is 2. My triangle is not very big, so I'm going to use arrows instead of putting it right beside the segment. Okay, so let's say this long piece over here, let's say that it's 6. Okay, if it is 6 long, then the shorter piece of that median is 3 units long. And then let's say that this piece is, let's go with 2. It's about the same length, nothing wrong beside it. So if that's 2, then the longer piece of the median up here is 4. So if we can continue our sentence, we've got all of my children are the next 2 words. So the M in my stands for median. The C stands for centroid. So all of altitudes, orthocenter, my children, medians, centroid. Okay, let's look at the centroid in some different triangles here. Okay, the orthocenter could be outside. Let's see if we can move this around so that the centroid is outside. So if I move A around, it didn't look like it. I move C, I flipped it over. That centroid is still there inside of the triangle. The centroid is always going to be inside the triangle. And it looks like it's pretty centralized in terms of being in that triangle. No matter where I move it, it looks like it really truly is in the center. A special thing about the centroid is that it's called the balancing point. So that's what this illustration right here is showing. If you were to actually make like a cardboard diagram here of this triangle and mark the centroid, you should be able to balance that triangle on that point. It doesn't matter what size your triangle is, your centroid will obviously be in slightly different places, but that is what we call the balancing point of the triangle. Now, is that something that you necessarily need to remember? No, but I wanted to share it with you anyway. All right, so all of my children, let's keep going. Angle bisectors. Okay, angle